there we go. Alright. For whatever reason, OBS was not working because the initial plan I had for this was to vocalize my thought process so that I can reinforce algorithmic thinking, which just means thinking out loud in the way I'm about to program things. And vocalizing things helps because it helps you to ascertain what you're thinking versus what you actually intend. And there's a small nuance between doing those two things here. So, actually, let me recap. Let me take a step back. And I need to record this bit so I can upload it as a solid milestone. This is cheers to me for 100 hours of deep work. If I am if I am replaying this in the future and I'm watching this, I want to remind myself that the little things matter over time. Brick by brick, you spent deliberate time focusing on getting proficient in Python, solving various problems, and you stuck to this Python drilling specifically over time. For other hours I did other things such as research, but you trust yourself for consistency. And this is just the beginning of another milestone. So, with that being said, I'm also going to talk about task 1 being completed at this time. We had a mic issue, so I had to check OBS and set the source of the microphone to my headset. I don't know why it got reset for whatever reason last time, but now that was solid. Task 1 was to complete a basic Python ETL where we, given a list of dictionaries of clients, you wanted to extract and filter out clients from a specific city and group them by age and name. We were successfully able to do that earlier. Now the next thing to do after that is the advanced concept using advanced data structures from Python, like generators, which help for scalability of large data sets that cannot fit into memory, and itertools group by, which is useful for grouping items from an iterable object, like a dictionary, a tuple, or a list. And so we're going to proceed with that. I'm going to switch over to the IDE just to showcase what the previous basic ETL looked like. Stupid simple, just using extract, transform, and load here. This is the output it gave. And we're going to move and proceed now to the advanced one. So let's begin with the hope of completing this within 40 minutes. That seems like a fairly generous time. Well, I'm not going to be looking at any coding utilities, just straight from, honestly, memory of what the problem is. So we'll try and follow along. Let's begin. I'm going to set the timer. My personal timer will be 25 minutes. If it goes over, then no problems. Keep working at it beyond this point. 25 minutes would be really good. Alright, so first thing I'm going to do is I'm going to create my acronym for data structures we'll need. I will do an import into tools, which we'll use for the group by later on. So be mindful of that typo. Alright, we're coding all this in a text editor so that we can reinforce best practices, right, without being carried by an IDE or like a smart editor giving us hints and pop-ups. So that's collections we'll use for counting number of frequencies for subscriptions later on, and then right now we need to do from typing. What we want to import are these data types, so that's what Go does for. I usually like to form acronyms to help me remember certain things. So use generators for large data sets, optional for data types for the age group that can be none, or it can be an integer. Then this is list, not linting. D is a dictionary, and N is for any data type which will be used for the values of our what's it called? We'll use any as representative data type that can integers or strings for our client data. So before that, we're going to encapsulate this in a class. So I'll say class, I'll say advanced ETL process, right? So take in clients, and what we're going to do is it's going to assign that to the instance of this class. That's simple enough. There are some things I should do here, like, you know, for instance, like what is clients, right? And part of advanced is defining the data types, but I'm honestly going to defer to do that last. I'm going to focus on functionality instead. So this will be a list of dictionaries, right? So you say the type, and in the dictionary is the key value pair, so you use square brackets to distinguish. Keys will be a string, like age, city, ID, subscriptions, and the value is going to be any type. That's why we have any at the top. Any, not any. And now we're going to start with our extract function. I want to showcase that advanced tool. So probably we would use data types extract clients by city self, so that we can reference this. If we need to access the clients, which we do, and here we'll put a string, because what we're trying to do is this will be the input parameter for the city. The city is going to be a string. What we're going to return is going to be a generated object, actually. So this here is what we want to do, is we want to specify, we need to also denote here that this would be none. Well, I don't need to, but I think it's important. Okay, generators. So generators is an advanced data structure that allows us to be optimal. Just realize that the type of optimal for getting large data sets. So instead of holding everything in memory, like if this was a list, generators would only return when we yield. So that's super efficient. So we have like 10 million clients, right? Instead of holding 10 million in memory, generators will help us do that. Now, I haven't even really practiced speaking out loud and doing this at the same time, so I find out I'm spending more time explaining my thought process along the way, which is being extra, causing extra delays, right? So maybe I'll code and then I'll explain as I'm reviewing. Alright, generators. The first argument of the generator is going to be the data type we want to return. So this will be a dictionary, basically of string and any type. The other two parameters we don't care, but it's basically what do we want the generator to send to the caller, or do we want the caller to send back to the generator. We don't have to go that advanced. It's not applicable to our use case. But now we want to start doing the validation portion of our of our function here. So before we process it, we want to validate it, right? So we're going to say for every client inside in self clients, which we initialized earlier, right? In the class constructor, we want to get a few things right. We want to check first if city exists inside the client. So that's a short data type validation. And then we also want to check if, I don't honestly believe we need this target city. I don't see why. I'm going to do it differently this time. We already have city as a constant. I don't see the point of having a variable for it unless it needs to be used multiple times. But we're going to check if the city we want is also belongs to this client. And we need to make sure it's in lowercase too, in case there's like a different casing for it. And if it is, we're going to simply return it. So that's where we have yield. And at this point, this is where the generator would return this to the caller. And we need to say elif. If the city is not inside here, this is the failure mode. So this is where the other part of the validation comes in. We're checking for a failure mode. Basically, if we cannot access the object that we care about, then we need to print a warning and just continue. And this is it. That's it for extract. Next. Okay, next. This is an important bit to do, right? We should test this. We should test this. We need to grab the clients again. Where did we have the initial clients? Okay, there we go. This is all we need. This is our input data set. So for all these clients here, we want to test our extract, see if it's actually working. So let's put that there, grab some of the clients, go to instantiate the object of our class, ETL-A, ETL advanced. I'm passing in the wrong thing, I need to correct that statement. That is not exactly true. So here we are initializing, right? And then I'll just call this extracted for the sake of time. For the sake of time, right? Then this argument needs to be among all these lists of clients here. Which are we looking to? We want to filter by New York. So we want all the New York clients. And we want to get a summary of their subscriptions, Netflix, Hulu, wherever they have. And then now, so that's extract, to transform. We'll say print. What we're trying to print here. We want to print out this generator, this generated object rather. So when this is being called here, this is when the generator is actually activated. It's not at initialization. It's at invocation, if that makes sense, or activation. Now we do expect some errors. Generators, there's nothing like generators, it's just a generator. That was a typo. I forgot to close parentheses here, so close that. And this is another weird thing that adds more extra time, which is the indentation in the text.txt file is different from Python itself. I don't know why that happens, but it does happen. Right. Sample clients. That's taking clients. Why is it complaining about that? Let's see. Self, list of dictionaries. I'll say I won't care. Let's run it. See what goes wrong. Takes no arguments. That's not true. Def, self, clients. What does it mean it takes no arguments? Advanced ETL process. Yeah, that's the same, right? But does this need to be called within a thing? Interesting. Hold on. Let's say if name that did not matter. Takes no argument. That's such a lie. Def self is a mistake. It's in it. Interesting. Okay, good. So it's working. We know we've got our extract portion done, so we're going to go back. Well, we could go back into our code, but let's do that. Let me just be consistent. Let me be consistent. Go back to the editor. Back to text. Pure black and white. Okay, so now we're going to transform by age group clients. At this portion, I'm going to be skipping the data typing. Then you'll try and come back to this when we have more time. But this is, let's name this extracted clients. And high level, I'm going to put a description of what we're trying to do here, right? So we parse the extracted clients into tuples, parse the tuples into iter tools group by. And then lastly, I also need to say sort by. What are we trying to sort by? So we get the clients, we're grouping them by age group. That's the thing, age group, right? Sort by age group. And then here I think we can just say sort by name of each dictionary. Okay, cool. So I think that's good enough notes for myself. We are going to get started here. Straight into the loop. What we're trying to do for clients and extracted clients. We want to create our list of tuples, right? So we're going to say age group clients. One thing we need to define, oh my gosh, is the age group, which is honestly boilerplate code, right? Get age group. I really don't like typing this part because but it's just so basic. So basically, if age is this, if the age is empty, then we return unknown. We don't know what the age is. Some clients might not have an age, so that's an edge case to consider. And then else, we do the ellipse. Now we start to check the range between ages, right? So if age is less than or equals to between 18 and let's say 24, then we'll increment and do the equivalent returns for the other ages. Return age. Oh my good. Then we'll leave that there. Yeah, between 18 to 20. Is this right? 18 is less than or equals to age. Age less than or equals to 18. Okay, yeah, that looks right to me. That looks right to me. There's this indentation that I'm irritated by. I don't know what it is with text editors. Like plain, you know what? Hold on. It's gotten way off. Okay, the next is going to be 25 to, let's say, 34. Here we'll now be 35 to 44. lastly, this will be what, 45 to 54, and 54 plus. Plus here as well, 45, 45, 44. This is 25 to 44. Okay. That twice. Okay, it's readable. Because none of these categories, you just say else under 18, right? So we've defined our age group. We can now use this age group in our filtering logic as we traverse through our list. So first we access and get the age of the client. We'll say clients get age. That's what we're looking for, but we need to put the string literal. And here we put our empty in case we don't have an age. And this is where we go if age and so if we have something that's an age, right, like it has a value, well, I guess in that case it would never come here because it would flag that we have an error, right? Or should we say if age, do we even have that key? Like, what if the key is not found? The client does not have an age. So if the age is inside the client, right, if the client has an age attribute, and let's validate that we have a valid age number, right? So age should be either an integer or a float, right? Like it should be a decimal or an integer, a whole number. And then lastly, we're going to do something where we return. We actually create our tuple. So this is where we use self to refer to this instance of the class object. And we get the age group, and then here we just pass in the client. And we need to store that inside our list of tuples. So we say append. Okay. So now that we've done this append, what does that leave us? We need to say else, if something is wrong here, right, we just print a warning that there's something wrong with the age, because that means we don't have an age attribute. Client has invalid age. Okay, then we pass in the invalid age here. And so the next thing we need to do is we assume at this portion we have our list of age group. The age group of each client is inside this tuple. So we want to determine how we want to arrange these, because that's going to be important for our itertools.groupby to be used. Call in a lambda expression. We say for each tuple, we want to sort this by the first element, which is what 0 represents here. And then we are going to, actually at this point, let's validate what we have so far, right? So we should see an ascending order once we print this of age groups, starting from, you know, let's say unknown, under 18, and then 20, 30, 50s of everyone from New York. Yeah, I think that's good enough. So we're going to come back. Instead of printing this here, we are going to say ETL, what's the name of our function? So avoid typos, I'll just copy this, come back, paste this here. We're trying to get those clients. Bless me. Trying to get those clients. Bless me. With passing are extracted. So passing are extracted, transform. So print the transform object. Since we know this is returning a dictionary, a generator. Oh no, it's not returning a generator. We did the generator part. We just expect, once we invoke this line, we shouldn't see anything printed. It's going to be none. But we should see the printout. So let's validate our logic. Age group list sort. I did it the opposite way, so I'm thinking of Go. That's funny. It's funny. Takes one positional argument, but two are given. What was it now? Get age group takes one positional argument, two is given. Is that true? Okay, great. This is really good. So we see 18 is the first thing that starts there. And after 18, we see 18 to 24, then we see 25, and then suppose we see 50. Okay, so the sorting is proper, which means we can continue. The next thing is our dictionary, right? So I'll just say dictionary of grouped age clients. So for clients in age. Oh wait, hold on. Let me go back to my editor. Let's be consistent. Okay. itertools group by. How does that work again? It helps us group the data structure, right? itertools.group by. What does this return? It takes in first our tuple, and then it's asking us, the key here is what do we want to group this by, right? And it's going to give us a key value, where the key is what we specified here. So the key is going to be the age. So we'll say for age group, and then the value is going to be all those clients that share the same age group, right? So this is actually, I'll say, client iter object. And the first thing we want to do here is access these clients. So I'll say clients equals to Now, one interesting thing to do here is we know that the clients, like this represents the tuple, right? So in the tuple, the first element is the more we remember, right? We group this by age group, clients up here. So we need to access the clients, which will be the second element. Because what the group by did is it consolidated all the clients, which is why we had to sort at this point. Consolidated all those clients into as a value for the group key, which was the age. So instead of having multiple options of several people that are the same age and then their client information, it grouped all of those together. So everyone that was between 18 to 24 is going to be inside this value here. So we won't get the first element. What we want to say is for, let's just say C in client tuple object. We want to get the first element. Which should be the client. And with that, what we'll have to do next is we can honestly start grouping, because now that we have the clients at this point, it's just easier for us to say, hey, this age group is the key and the value is going to be the client that we've extracted from here. Now we're using sorted because we can sort. This is honestly skippable. I should skip this, but we can sort it. It's good. It's a good indicator of how we can advanced concept where we can sort the elements of the clients by age. No, by name, by other means other than the age group. So let's say we have multiple people. There's several clients we have between the ages of 18 to 24, right? And you see Alice. We also see Grace, and then we also see, later on, there's Charlie, but that's for a different age group, right? 25 to 34. Well, basically, we want to make sure that when we group them, we sort them by their name, so in alphabetical order. So this is a good way of doing that as well, which is why I was contemplating earlier that it's not necessary, but it's nice. So this should be the heavier piece. Once this is done, the summary, the last bit, should be easier. So we are going to now print the transform as we have it here. But let's see now in our editor any mistakes we've made. There are a few. I should have ended that with a colon to inside the array now. And what doesn't it like here? Lambda x is what we want to. That is the small nuance in the denotion of the lambda function. Okay, so I'm going to run this. And did it do the grouping? Let's see. So I'm going to look for this. Okay, yeah. So it did. Before we saw multiple instances of 18 to 24. We saw Alice and Grace had their respective key value pairs, right? As tuples, because that's what we printed. And then now we see that Alice and Grace are both between the ages of 18 to 24, like 22. So they had one, we successfully grouped these clients, right? Same thing with Charlie, same thing with Eve, 55. So okay, so we have our dictionary, and the last we have to do the loading piece. Finish the advanced ETL concept by hot. Where is the age, extract, transform, load. I was just checking indentation there, so I'll say load client summary. The client summary basically just has a gist of like the clients, right? It has their ID, name, age, and subscription. And so it's going to take the, what's a good name for this? Oh, let's give it the same name. Yeah, it's inside a different function parameter, so we don't have conflicts. Then now at this point, what we're trying to do, we want, there's several things we want in the summary, right? The summary should return three things to us. It should return the total unique clients that we have. I'm going to use a set for that, because we'll insert that by ID. It should return the total subscriptions of the clients. I think we'll probably use this as a helper, but this is where collections.counts comes, so that we count for every subscription type, like YouTube, Hulu, Netflix, how many people are subscribed to those, so we can see the most popular one, right? As part of the summary. What's the most popular subscription? And then lastly, we need the actual client's summary, which will be a dictionary, right? So within our dictionary that we have there at the bottom, we're going to say for age group and the clients. It's a list, right? Yeah, so we should say clients. Then we denote this or expand it by items to give us the keys and the values. We're now going to say if, now we can start constructing our summary right here, right? So let's have a count. Do we even, wait, do we need a count? Do I need to put a count here? So we'll grab our client summary. We're going to try and do something smart, and we're going to say, okay, the summary of this age group, right, has a few things. This is the total number of clients it has. So we're going to have a summary called count client. Or just count, let's keep it simple, right? And then this is the length, number of clients for it. What do we have after this is, we then have our summary, right? And our summary is going to be a list of metadata for the clients, just initial information. But how do we get this information? Well, we access the clients, right? And we say for C to represent each client, right? Like Alice and Grace down here. Let's then access the names of these clients. So C.get. So what we're trying to get here? We're trying to get, say the age, keep it simple, age, name, subscription. But we're not even storing this anywhere, so it's almost like, wait, wait, what is this this summary? This summary should be in a dictionary, actually. Yeah. Yep, this should be in a dictionary. So it's a dictionary of dictionary access from a list. So we'll put page here, and then we'll access the age. I think it makes sense to put name before the age. Actually, I don't think the order matters. Let's look for completeness first, and then we can change things. Name. really don't expect them to not have an age, but I think it's best practice to also do that. Name, and then lastly subscription. And lastly we have the subscription, this dictionary. Alright. Remember the subscription is an array, right? Of the type of subscriptions they have. So if there's no subscription, you'll just return empty. Okay, so that's our detail for seeing clients. Then we have this list of metadata for our clients. So what does that leave us with? That leaves us with information we need for the total subscriptions and the number of unique clients. So at this point, say for CRM clients, we'll just say C. So what do we want from here? We want to store, we can basically use the ID. Let's try and get the ID, right, the client. So we'll get the IDs. We use a set because if we have multiple clients show up, right, the ID is the identifier for the clients. So if we have multiple inserts for these clients, right, then a set makes that unique. So it's just good out of the box for uniqueness, and then since it uses a hash table. And then lastly, we want the number of subscriptions. This is where our iter tools group by comes in. So here, first we want to extend, since we know it's an array, we want to expand that array and add that the array of subscriptions, or the list of subscriptions, into the existing one. This is what this extend is doing. Now that we're out of that loop, we can say total sub count. We'll start using our, this is the second part of advanced Pythonic programming, where we use collections.counter to help us count the number of subscriptions we have. So this is all we need as far as I'm concerned. I think we have to pass this into a list. If it's not, when it breaks, we'll find out. And so yeah, at this point, that's looking good. Simply just return the summary information, which is going to contain all these things. Yeah. That's this. We'll be putting the values for each. Don't forget the commas. So client summary should be the client summary. Total subscriptions should be the length. So we're going to count the length of that. And then total unique clients. Well, that should be swapped. Total unique clients should be just the length, because that's the set, right? That we've already calculated. And then total subscriptions types we have can be represented here. We'll switch the order as well. We'll have our client summary information, number of unique clients, and then total subscription. This client summary is by age group, so it will let us know like the summary of each age group, right? And then lastly, we're just going to print this out, because this would mark our completion. Call this loaded. Skip this. Where's our loaded summary? It's inside here. Let's close that. Loaded summary then needs the transform, which basically has our initial dictionary. Then we just have load. So now we're just going to copy and paste this. Success or completion is the we have that output of the summary showing properly. ETL load summary. Probably completed loaded. To need to use the right variable. We have some things here that don't make sense, I guess. Extend subscriptions. I should say c.get subscriptions. We need to access it first because it doesn't know what subscriptions is. We need to pass in the literal of it. Yeah, if it's empty, just pass in an empty array. The collection, if you want collections with an S. Okay, let's run this, see what we've got. Oh, there we have it. There we have it. We need to stop the timer. How long did this take us? We successfully did this within 14 minutes, but it was 25 minutes. One thing I could have done programmatically is also to start a timer, but we have to do it in bits, so I don't know how that would have worked if I have to stop the program at different parts of extract, transform, and load. It's 18, okay. 19 plus 100. Okay, so barely. Actually, that took us over 43 minutes, but that's shorter than we've ever done it before, so that's good. Nice. We have a client summary, and then I know it's hard to read, but okay, next thing is subscriptions. These are the different type of subscriptions we have. Total subscriptions. Oh my god. Okay, there we go. Loaded as a list. Is the summary right? I know this is sort of hard to read, so let's actually let's print this out properly. For K, comma V, and loaded item. So what this should do is it should print us the keys, which is what we have here, like client summary, right? Shows us the client summary, total unique clients, and the subscription and the frequency of the subscriptions that we have for each client. Okay, let's run this again. Total unique clients 7. Total subscriptions are here too as well. Okay. The only thing I feel that's odd, I don't know what to say about it, is should this be a list? I know we're passing it as a list, but what is this actually? Or should it be a dictionary? Because collections.counter is supposed to count the frequency for us. So if my hunch is right, it wouldn't. When we pass this as a list, Python implicitly just let us know, oh, here's the total number of unique subscriptions you have. We should see the count here as well, right? So we're going to run this program again. Okay, perfect. So our assumption is right. So from all our seven clients from New York, and we know it's New York because we did filter by New York. That's from all the clients here. We know from our 7 clients from New York between the ages of 18 to 55, 4 of them, there are 4 subscriptions that are from YouTube, 4 are from Netflix, and 2 are from Hulu. Because some clients have multiple subscriptions, right? So it won't be like a one-to-one relationship. It's actually a one-to-many relationship between clients and subscriptions. And so the most popular among these would be YouTube and Netflix subscriptions, and the least would be Hulu. So at a high level, you know, what this sort of programming in Python is helpful with, or this drilling of programming, is it helps with programmatic thinking or algorithmic thinking, right? You saw several times where I made a mistake by not using the IDE and just using plain text editor, right, like a TXT file. I was forcing myself to practice correctness. And with correctness being practiced, we're able to complete the program properly by noticing mistakes here, right, when we actually try to run it. And so, from a, I guess, learning standpoint, the more you practice drilling a programming language, solving the same type of problem, though, but using different data structures to process things differently, the more proficient you're going to get, and the more you're able to self-correct. And moreover, these sort of mistakes of when I execute something and look at the terminal and go, oh, what's wrong? And I'm able to identify what's wrong. You're able to iterate through failure in a better way, right? So you fail better, then you get better. But none of that would happen if we didn't try this the past 100 hours. And it wasn't just this, there was a bunch of other things. It wasn't always programming, like sometimes you guys would just see this, this screen here. You just see the screen here because there are things I can't cover off screen. But we did make it. We did make it. Oh my god, I forgot to stop recording. Onto, like, locally, because I was recording the first bit of the introduction. But I guess I can clip that part, I can clip this part, and then add that to the playlist or something to look back on. The next plan is to continue these hours of studying, but probably start a new channel where I'm actually trying to build something. I'm vocal about my thought process. I think vocalization is helpful for when you're pairing. Communication is a very core, important skill in general. The more you're able to communicate, the more you have clarity, but communication is also going to fail at different levels. Oh, with that, we did it. That marks 100th hour of deep work. Very proud of coming this far. And there's going to be more things ahead. This is the end of this playlist series, or the ending of it. I'll probably do a few more, and I'll start a separate channel where I will build with the knowledge that I have, build things, fail better, then we get success, iterate. Setback is a setup for a comeback. None of this would happen without trying, so cheers to that, keep on keeping on. Yeah.